Hello everyone and welcome to this share session. This session will discuss DevOps opportunities with IMS, and with enablement of those DevOps opportunities, you should be able to enable ROI within 1 year of adopting DevOps practices. My name is Dwayne Winty and I'm an advisory software consultant at BMC Software. BMC has done a mainframe study over the last 16 consecutive years. And this last survey that was done was conducted with over 1,100 executives and SME experts in the mainframe space. What we've noticed over the last 3 years is that DevOps has been growing in priority across the mainframe platform. 78% of those mainframe users have indicated to us that the ability to make changes more quickly to their mainframe applications is very important to the business. 56% of those responding to the survey indicated that they are now using DevOps on the mainframe, and 77% of the executives reported that their organization have DevOps practices in place. The key to that number is that since 2018, that has increased from 33%. The last statistic here, 74% that have implemented DevOps have reported seeing ROI within 1 year or sooner. Also as a benefit, key benefit of DevOps on the mainframe is that they indicate that they get greater stability of their code. They get improved application quality, so they get less problem leaks into production, and they've also seen improvement in security. You can get a copy of this mainframe survey by going to the link that I have on this slide. So there's still 44% of those mainframe people that were involved in that survey that really don't have no DevOps in their environment, or are not considering DevOps. So what is DevOps? Well, it's really not a software, piece of software. It's not code. It really is a process. And it had its early beginnings with Agile development. Agile development was really designed and implemented such that it would bridge the gap between those people that are involved with the development process, the developers and QA, so that they could create more effective and efficient software. And so that at the same time, the QA people that were testing the code could give the problems in the code that development generated as a result of those changes. They could give that back to the developer at an appropriate time so that it bridged the gap between the developers, QA, and also on the ops side, as we're moving into DevOps, it brought together the operational side of the equation so that once that application was delivered in production, that the apps people understood what the application was to do so they could build the infrastructure correctly. They could do validation, deployment, and delivery much quicker, and also support the application. Before DevOps, as you all know, we were using the waterfall development technique to develop our applications. There was a huge analysis project that was done that tried to design this whole application or application change. Once the analysis work was done with the business, then it was given over to an architect, and the architect would try and pull together the right kind of infrastructures to support that application or maintenance of that application. Then finally, it was given over to the app dev people to develop the code, and ultimately it was then thrown over the fence, or like the waterfall says, given to the testers to test it, and then ultimately it got over to the operations staff for them to maintain it and deliver it to the business. Well, that particular development effort using waterfall took a very, very long time, months, sometimes years, and it really didn't address the needs of the business. And what developed was a really natural love-hate relationship form between these individual groups. So change is needed, and that change is really the process of DevOps and the terminology that it brings to the table. It involves you integrating the mainframe process into your continuous CI, continuous integration, or CD, continuous delivery deployment tool chain, so that you can add the appropriate amount of automation such that those people that are doing the work understand the reason why they're doing the work, and so that they can increase the velocity that they're delivering the code. They can improve efficiency for those that are doing the work. The quality is also increased such that you don't have problem leakage into your production environment, and also at the same time be able to manage and measure the performance of that code and also the efficiency of that code. The DevOps goal is really a same team approach where everybody is really tightly integrated, and such that you get improved deployment frequency, you achieve faster time to market, you can lower the failure rates of new releases, you can shorten the lead time between fixes, and you can improve the mean time to recovery. All of those are achievable objectives by implementing the DevOps process. BMC really has a DevOps tool chain that really has two sides of the equation. If you look at a DevOps continuous integration infinity loop, the first part of that is, or the left-hand side of that tool chain is really those solutions that are going to be used to improve the application development process and to really give next geners the ability to be successful developing mainframe applications. The other side of the equation, which I'll talk about later in the second half of this session, is on the operational side. And we have many solutions in the operations side that fills that tool CI/CD tool chain in that infinity loop. Essentially, DevOps functionality needs a modern, intuitive IDE platform to enable and equip the next generation set of developers. They need to be able to quickly access productivity tools, and that productivity tool that's being developed by BMC is the CompuWare Topaz Workbench with integration into ISPW for source code management, so that you can quickly deliver, edit, deliver, and compare code that's being written, so that the testing and code delivery velocity, efficiency, quality, and measurement can be achieved. This ID platform gives the ability to quickly access necessary productivity tools to analyze, edit, compare, manage, test, and debug in the most efficient way possible. The CompuWare Topaz developer experience really is the ability to improve analysis and ability to edit and change the code, the ability to do concurrent testing across the whole development lifecycle, and then also integrate the promotion of the code into a CI/CD toolchain if you so desire. Switching on the runtime visualizer, and expediter will dynamically draw the program calling chain in Topaz for program analysis. This allows the programmer to quickly determine what programs are involved and how many times they get involved. It also shows the files and databases, use visualizing real execution of the application all within seconds, saving potentially days of analysis time to increase velocity and also to improve quality. Analyzing and editing the code as developers make changes to code, they need to quickly understand unfamiliar or complex mainframe applications. They need access to intelligent source code editor via Sonar Source and SonarLint, which is going to strengthen that code quality and adherence to standards. On-the-fly quality checks enable earlier issue resolutions to prevent future difficulties and expenses, and really minimizes code complexity to ease maintenance and troubleshooting over time. Being able to edit and test the data concurrently with the development lifecycle is very, very important. If you are developing code using 3270 ISPF today, then you can only be as productive as you were decades ago. Attaining an agile DevOps process will not happen. Being able to create test data unique to your testing requirements in parallel with the development lifecycle is necessary to improve code velocity and code quality. Viewing a DBD to understand the segments, relationships, and fields in parallel with coding effort is also seamlessly possible with BMC CompuWare Topaz for total test and BMC CompuWare for enterprise data. BMC's CompuWare's ISPW product allows you to build and deploy at the speed of DevOps. It provides a web interface to view status of deploy requests and environments where code is deployed, diagnosis and fix issues with suite of troubleshooting tools via the Topaz Workbench, and use the interactive, intuitive hierarchical chart in the event of failed deployment to pinpoint failure for corrective action, and allows you to remediate bottlenecks or other issues in code promotion to ensure smooth delivery process. On the other side of the equation, most people monitor the performance of a product after it gets into production, but that's counterproductive. It's very, very important to integrate the monitoring of performance and CPU utilization at the same time that you're actually developing the code, so that you can prevent performance issues before the production environment is affected. You need to compare the performance of various runs to see where differences are occurring. You need to see differences between new jobs compared to the original job. You need to understand where in the application CPU is being consumed so that there is opportunity to improve that code from a performance perspective. You can do so. And then also, as you are using the CompuWare Strobe product, it provides you the ability to leverage the Jenkins plugin and also the CompuWare Strobe API to automatically trigger performance measurements in your CI/CD pipelines. So that is on the application development side of the equation. Those solutions that we acquired there has moved BMC's traditional operational side of the IMS process to the AppDev side to allow us to improve the developer experience from an analysis perspective, a change perspective, a integrated testing perspective, and also from the standpoint of being able to effectively integrate the code promotion process into this developer experience as well. So that's the left-hand side of the DevOps toolchain infinity loop, DevOps infinity loop. It's the AppDev side. Now I'm going to move to the right-hand side of that infinity loop, which is the systems operational perspective, which is the systems administration perspective and also the perspective from the database DBA perspective. The first side of that is BMC Change Manager for IMS TM, which includes a DevOps for IMS Jenkins plugin. So let's talk about that. What we've done here is we've modified our dynamic resource definition solution, our Delta product, and integrated it into the DevOps process by implementing a Jenkins plugin that will allow you to create and edit Delta lists. It allows you to check those Delta lists for validity against the IMS control region to make sure that you don't introduce invalid updates. And it allows you then to execute the Delta list to make the changes dynamically. All of the changes are logged such that if you don't get the desired result, that you can back those changes out to prior to when those changes were made. This product uses the ZOSMF REST API to submit and run jobs on ZOS. And if we look at the image at the right, I've given you an example of how this process works. The development team in this case requested a transaction to be updated or added to the IMS control region. And in this case, the source code is being sourced in GitHub. That source is being extracted from GitHub, and then the build process in the Jenkins plugin is started, and you will build what you would need to do, add, change, replace, delete, whatever that is. And once that build process completes successfully, then it triggers to execute that Delta list under the covers, which the technology that's doing that is our Delta Plus technology to add the Delta list, to check that Delta list, and to execute the Delta list. And once it's executed, then the IMS control region has been changed, and those changes are available. As I said earlier, the Toolchain tool of choice for this integration, the DevOps Toolchain integration is Jenkins. And you can see the Jenkins Workspace for building that Delta list in the right-hand image. This Jenkins plugin supports all actions that can be done in a Delta Plus Delta list process. All actions are supported. Creation of the Delta list, editing of the Delta list, checking the Delta list against what is currently defined in the IMS control region, and then of course executing that Delta list to make those changes that you've requested in the production IMS environment. The workflow really says what action, answers the question, what action do you want to take? In this case, the example that I'm using here was that add transaction macro. What are the mainframe connection options? You're telling the Jenkins toolkit or Jenkins plugin where you want that change to take place. Then what BMC Change Manager for IMS options are you going to select for this action? And then it generates the Delta list job that can then be submitted and executed. Once the job completes, the job log output is then passed back to the Jenkins Workspace so that you can see in the Jenkins Workspace whether that Delta list executed correctly or not. All of the Delta list elements can be are supported. The application macro, the transaction macro, the database macro, Ryotko, and so on are all supported through the Jenkins plugin. That's the operational side. We're adding automation, and we're providing a plugin through the Jenkins plugin to be able to introduce IMS systems administration changes into your CI/CD tool chain. This is the other side of that operational equation. This addresses automation from a DBA perspective, and this is BMC Change Manager for IMS. This particular solution addresses changes to DBDs and PSB control blocks. It is written in a easy-to-use graphical editor that's written in ADAPT HTML5. All of the GUIs at BMC are moving in this direction. It allows for activation of changes to those control blocks, and it also provides an undo capability so you can back out those changes should those changes not give you the desired effect. It supports both the IMS gen process for the DBD gen, the PSB gen, and ACB gen. And it also supports the IMS catalog and managed ACBs. So as customers are transitioning to this stated direction in the IMS space, that this tool will provide a seamless integration and allow you to transition very, very easily. The key part and the heart of this system is really the impact analysis of the database changes that you're making. The impact analysis, what it does is it determines can those changes be effectively done? And secondly, what are the changes that are going to be made? So it tells you exactly based upon the changes that you've made to those control blocks, what kind of operations are going to be required to implement those changes. This particular GUI also provides supporting applications, such as the ability to interactively generate IMS type 2 commands. In other words, what do I mean by that? Well, we provide you a pull down of all the IMS type 2 commands, and you can select the command, and what we will do is we will provide all of the valid options that are available for that command. You select the option, and we provide also the ability to know what the requirements are for those options. And once you select the options, what we do is we dynamically build the type 2 command. And then once you're finished with the options and have built the command, you can submit that command through the console and get the results back of the execution of that command. We also provide a dynamic IMS buffer pool tuning tool. In other words, we give you the capability to view all of the IMS buffers. And if you were having a performance issue, you could review the buffer pool tuning space application in the GUI. And what it would do is it would tell you if altering the buffer pools could potentially improve performance. BMC Change Manager for IMS objectives. This is what we're trying to do. We're trying to simplify IMS maintenance so that universal DBAs and experienced DBAs can have the same experience, and to simplify the IMS maintenance. It provides an ease of use for supporting the IMS from those two control blocks perspective. It reduces the risk of making database changes so that when you make the change, that change will be accurate and done accurately the first time, every time. And of course, we want to meld the personas into a single persona, experienced persona that helps reduce the skills gap for universal DBAs, which we're seeing more and more in the IMS space. These are the two personas that will be affected by this solution. Experienced IMS DBAs, they're comfortable using the IMS gen process. They've been using it for a very, very long time. They're also not so experienced using the IMS catalog. That might be new to them. They're experienced using ISPF, and they're also understand JCO and batch jobs because that's what they've been doing as long as they've been maintaining the IMS environment. Universal DBAs, on the other hand, they're comfortable using DDL. They're used to using a catalog to support database activities. They're experienced using the GUI interface and less experienced running JCL. So this solution will meld these two personas so that they both can be very effective managing the IMAS environment from a database and program perspective. Everything that's done in this console is done from a project perspective. All DBDs, PSB changes are done in a project. Doesn't matter if a project has 1 DBD or 1 PSB, or it has 10 DBDs and 5 PSBs. It doesn't matter how many control blocks are added to a project. Once you define a project, that is what's going to be managed by the change manager product as a piece of work. Once you make the changes to those control blocks, the analysis engine takes over and it says, are those changes syntactically correct? Are those changes logically correct? And oh, by the way, what do those changes require from an implementation perspective? And then it generates the JCL to make those changes correctly the first time, every time. The projects are managed in projects for audit purposes, and also gives you a back-out process to be able to undo changes that didn't result in the expected results. It's all about reducing risk of DBD and PSB changes by maybe people that aren't so experienced managing IMS. It allows you to do impact analysis, shows you what will happen and why it's going to happen. The generated change jobs will not miss any steps. So you're going to be successful the first time. You're going to be successful every time you make changes to these control blocks. And then, of course, if the changes don't result in the desired effect, you can quickly undo those changes that were implemented in the project back to before those changes were attempted. There's a source code reviewer, so you can disassemble the macros in gen format, and you can also by a click of the button in that window allow you to show that control block in DDL format, which maybe the universal DBA understands more. And also, if it's an experienced DBA, allows an experienced DBA to understand what that control block will look like to a distributed developer if you're doing access to IMS databases from a distributed platform. You may also have requirements to look at the DBRC changes, especially if you're maybe migrating from a full function database to a HAL DB database. There's DBRC changes for those partitions, and you may want to review those. So we provide the ability to look at that source from within the console. All of the jobs that get generated to implement those changes are generated in 5 sets of JCL. The README document indicates to you who made the change, when the change was requested, and when the change was requested or implemented. And the second thing it tells you is what is being done with this change. The setup actually takes the requirements and backs up the control blocks, and it allows you to build the project files. Everything that would be required to implement this change is added to the change manager repository in the project file. The commit one actually takes the project file, does a backup of the database. First of all, backs up the control blocks, so you have backup requirement, and then also implements the project requirements from the project data sets into the IMS appropriate data sets. Now, at that point, those control block changes are sitting there ready to be implemented online, but they're available in case the applications group needs to make changes before those changes get implemented in IMS. The commit to job stream then uses Delta Plus under the covers to dynamically make those changes to IMS without having to do a mod blocks gen or online change. And the last job, of course, is the backup job to be able to roll back to before when this project was implemented. BMC AMI Change Manager for IMS really does make less experienced universal DBAs more effective. It assists experienced IMS DBAs with the implementation of the IMS catalog and managed ACBs, and it reduces the risks of making changes incorrectly to your IMS environment. It protects the IMS environment and helps you be more effective. I want to leave you with some statistics, and these statistics were derived from a Forrester report. And when we look at the BMC DevOps toolchain, the left half of this infinity loop is those solutions that I talked about from CompuWare, which are the Topaz Workbench and the Topaz tools that are integrated into the Workbench to manage the whole development process. And the right half of this infinity loop is those BMC solutions that fit the operational side of the equation. And in this particular session, what I talked about is the change management solution for IMSTM and also the change management solution for the database area. If you implement these DevOps solutions, what customers have told us is that 77% believe modernizing the mainframe development tools will increase velocity, the rate at which you can make change, by 18%. Another very, very important statistic that is derived from that Forrester survey of over 400 subject matter experts on the development side is they indicated 62% said modernizing mainframe development tools increases quality of applications by 23%. This report, Forrester report, is available to you simply by pointing to the link that I have at the bottom of this slide. My contact information, if you have any questions related to this session, please don't hesitate to reach out to me. This is the contact information which you can reach me at. And the last thing, please provide your feedback. It's very, very important to the SHARE organization, so please submit a SHARE evaluation for this session. I would like to thank you for taking the time to review this recorded session. I hope you enjoy the rest of your SHARE. That concludes this session. Thank you very much.